Okay, welcome to 4.3. Before we jump into our handouts, I want to take you to a separate handout I created here just to show you some basics about quadratic equations in vertex form. Everything we do in grade 10 math always relates to what we call the parent parabola. Okay, so what we want to discover is, what did we do to the parent parabola? Did we move it left? Did we move it right? Up? Down? Does it open upward? Does it open down? Is it stretched? Is it compressed? All these terms will make sense to you as the lesson unfolds. But let's take a look at the basics here. Y equal x squared, again, is our parent parabola. If we want to graph that, let's make a table of values. Now, I already know if I plugged in 0 for x, I would get 0 squared, which is 0. So that's going to be the vertex of my parabola. So I'm going to plot that on the grid. So when I look at 0 here on my table of values, 0 squared would be 0. So these y values are for when x, I'm just using this, x squared. So if I sub in -1 for x, I get -1 squared, which is +1. But when I sub in +1 for x, I also get 1 squared, which is 1. And you can start seeing the symmetry happen here. On my grid, when x is 1, y is going to be 1. When x is -1, y is also going to be 1. I'm just sketching here for now. When x is a +2 or a -2, -2 squared is +4, and +2 squared is +4. So on my table of values, those become 4s. On my graph, when I plug that in, 2 is about, reaches 4, -2 reaches 4, about here. And then 3 and -3 squared would both equal 9. So maybe something up here. Something like that. And if you try and graph it, it would look something like this. Something like that. I prefer if this is a little further out. So maybe a little bit more like that. Okay, so let me fill those in on the grid, 9 and 9. So you can see the pattern and the symmetry in the table of values, but you can also see the symmetry in the graph. The y-axis is my axis of symmetry in this case. It's symmetrical on either side of the y-axis. But what happens if we make a change? So for example, what if I change the x squared and I put a +2 at the end of it? So I'm going to write here x squared +2. If we added 2, what would happen to my values? Well, I know if I plugged in 0 for x, I get 0 squared, which is 0, but then I'm adding 2. So now my value is increased by 2. If I plugged in a 1 or -1 in for x, I'd get +1, because -1 or +1 squared is 1. But then I'm adding 2. So now that value becomes 3. If I plug in 2 or -2 squared, they become 4. But I'm adding 2, so that becomes 6. And then for the 9, you guessed it, it becomes 11. If I plug in 3 or -3, we end up with an answer of 11. Let's see what that looks like as a sketch. I like to start right in the middle at when x is 0. And then we said that 0 squared is 0, plus 2 is 2. So my number, or my dot on the grid, is about there now. And if I go left of when x is 0, if I go to the right to +1 or to the left to -1, we said that the value ends up becoming a 3. So when I go to 1, instead of being at 1, like it was with the parent parabola, I'm now at 3. And so same thing here, I'm now at 3. And instead of when 2 squared is 4, now I'm going to be at 6. Something like that. And 3, instead of being 9, is now 11, which is a little bit further than I want it to be. But for all intents and purposes, what you can see here is this parabola is going up like this now. It's the same parabola, it's just shifted up 2. The same thing would hold true if we decided to write a +7, for example. If I wrote +7 instead of +2, then the whole parabola would shift up 7. If we wrote -2, then our parabola would start down here at 0, -2, and it would just be going up like that. If we wrote -5 after the x squared, then we'd be going down to -5 on the grid, somewhere down here, and the parabola would just open up like that. Now, what makes the parabola open up is really what's happening in front of the x squared. There's an invisible 1 hiding right there. And that invisible 1 being positive, a positive, what we call a value, there's an invisible a value or a 1 here. When that a value is positive, the parabola opens upward. So what we just drew can technically also occur upside down or opening downward. For example, -1 and -1 would be here. 1. So what I'm graphing now is y equal -x squared. All that will do is turn your parabola upside down, and basically it'd be something like this. Like the parent parabola, just opening down. Okay, and if we said -x squared -2, then it'd just be down here and going down like that. So all these values can occur also opening down as long as the value in front of the x squared is negative. All right, let's look at some other options. Another option might be, change the color here for you. Another option might be, what if I don't add 2 at the end, and instead I put a 2 in front of the x squared? Well, the 2 is still positive, so I know it's going to open up. But now what's going to happen to my values? Again, I'll start off in the middle at 0, 0. When x is 0, 0 squared is 0, but now times 2. Well, I know 0 times anything is still 0, so that doesn't change, which means my vertex is still going to be at 0, 0. When x is 0, so is y. When I plug in 1, 1 squared or -1 squared is 1, but then we're doubling that times 2. So those 1s now become 2s. Again, the parent parabola, when I plug in 2 or -2 squared becomes 4, but now we're adding 2 to that, so those become 6s. And then if I multiply 3 or -3, square it, sorry, that becomes 9, like our parent parabola, but now we're adding 2. Sorry, we're doubling. Oh, did I make a mistake there? I think I did. I apologize. That was an error. We're multiplying by 2, not adding 2. So I got to change that up. When we are adding a 2 in front, we're doubling, not adding 2. So I apologize. So when we have a 1 or a -1 in this situation, -1 squared is 1 times 2. That becomes doubled. But then when we plug 2 in, or -2 squared is 4, we double it and it becomes 8, not 6. That was the other example. And now if I plug in 3 or -3 squared is 9, but doubled becomes 18. So you can see those numbers are far greater because we're doubling everything. That's all they are. Basically, in fact, 9 became 18, 4 became 8, 1 became 2, 0 doesn't change, 1 became 2, 4 became 8, 9 became 18 from our parent parabola to this. What does it look like as a graph? Again, 0, 0, so we can still graph at 0, start beginning our vertex at 0, 0, but instead of being 1 squared and 1 right here and -1 on our parent parabola, we're going to double that. So now we're going to be at 2 and -1 squared, and then that'll also be at 2. And then when we're at 2 on the x-axis, instead of being at 4, we're now going to be at 8, way up higher. And -2 is also going to be at 8. And I won't even have room to fit 18. When x is 3 and -3 gets 18. But we can kind of get an understanding of what's happening here. If you look at this parabola in purple now, it's a little skinnier than our parent parabola. We call that a stretch. It's like you grab the arrows and you pulled on them. What you also know is that it's going up doubly fast, so to speak, right? At twice the rate of the parent parabola. Now, I can draw that upside down. If we made that -2 in front, that the exact same thing would occur just down below. And it would look something like that. Okay. Let's try something different here. What if I didn't make it a 2 and we instead used, let me change up the color here. I guess I can use orange. Let's say we made that 1/2 x squared. What would happen now? So again, the number in front, 1/2 is positive, so my parabola is still opening up. If I make it -1/2, it'll just open down. But what happens when we have x squared? Oh, sorry, 1/2 x squared. And the last one was, this was for 2x squared. So for 1/2 x squared, you might guess that instead of doubling like we did when we multiplied by 2, now our numbers are going to be cut in half. So half of 0 is still 0. Half of 1 would be 0.5, and -1 and positive 1 would be 0.5. Half of the 4 would become 2. That would become 2. Half of 9 would be 4.5. On the grid, we know the parent parabola, when x is 1 or -1, -1 or +1 squared becomes 1. But in this case, it's going to be 0.5. So if you look on the grid where I'm drawing the dots now, it's half. It's going up half as fast, or half the rate of the parent parabola. Instead of 2 squared being 4, now we're going to be at 2, because again, we're going half the rate. And instead of 3 squared, we're going to be at 4.5. So we're out here. So my parent parabola is the blue, and this orange one is going half as fast. You can see that it's going half the rate. Okay, so it looks wider. We call that compressed, or as if you push down on the arrows to compress. Okay. Now we're going to take a look at some of our other handouts that I have for you. On one of the main handouts here, I've got a bit of a demonstration. If you like, you can click on that link, and what you will see is this demonstration to see what happens with vertical shift, horizontal shift, and dilation factor. That's the part that makes it skinny or compressed, stretch or compressed, right? But the horizontal shift moves left and right. And then take a look how it affects the parent parabola. So you see that parent parabola is y = x squared. If I were to shift it upward, we said if we shift it up 2, for example, x squared plus 2. So if I play with this, you'll see that as I move this, it doesn't want to move, so I'm going to refresh that screen. That might have just frozen on us for a second there. But when we play with the vertical shift, you'll see the parabola start to move upward. Just give it a second to initialize. There we go. So vertical shift. If I move that, I moved it to 1 or 1.03. It's really hard to get this exact when you're playing with these sliders. So I got 2.09, but try and get it down to 2. I got 193. Close enough, 2.04. But you see that the parabola moved up. If I went down to -2 territory, all that happened is my parabola is now beginning or initiates at 0, -2, or -2.11 in this case. But see how it affects the equation? And I'll try and get this back to 0. That's a little tougher than it seems. So for me, it'll be easier to just refresh the screen, because I want to get back to y = x squared as our parent parabola. And then you can play with the slider and see what happens with horizontal shift or stretch or compression factor. Now, the stretch or compression factor, the dilation part, is the number that's in front of the x squared. Remember, if right now there's an invisible 1 hiding in front of the x squared, but if I change this top slider, the dilation factor, the stretch or compression, if I increase that, right, so now it became 2.15. The parabola, look what's happening to the parabola if I keep increasing it. It's getting skinnier and skinnier. Again, it's like you pulled on the arrows at the top and just stretched that. But if I go the opposite direction and the number in front of the x squared is now negative, look, it opened down, right? Let's keep it in positive territory if we can. But let's go somewhere between 0 and 1. If my parabola is between 0 and 1, in this case I have 0.28. The example I used with you before was 1/2. So let me try and get it to 0.5, or in that territory at least. There, 0.5 on the money. You'll notice that is half the parent parabola, 0.5 x squared. And if it goes greater than 1, now it's going skinnier than the parent parabola. If the value in front of the x squared, if there's just a blank there, we know it's an invisible 1, and then our parabola has not been stretched nor compressed. What about horizontal shift? Horizontal shift takes translates our parabola left and right. This one's a little bit tricky, but look what happens to the equation of y = x squared when we apply a horizontal shift. So now I'm only going to use the middle slider on our demonstration here, and take a look at this equation, what happens when I change that to something more positive. So now, interestingly, my x value is 1.45, but now inside the bracket it says minus or negative 1.45. By a 1.45 is a positive value. And we went to the right 1.45. The equation is x minus h, h being the horizontal shift, in brackets squared. So if I know if I'm moving right, then that's x minus my 1.45. If I go left, let's try that. If I go left, I was trying to get 1.45 there, but again, that's not as easy as you think. I got negative 1.42, close enough. But x minus h is the equation in brackets. But now we're at x minus, we said we're going left to negative 1.42. So x minus, and the h value is negative 1.42, minus negative is like saying plus. That's why it shows up as plus 1.42. It just means that we had x minus a negative value. And so we are now left. A mental hack is just to look at the equation and say, look, it says x plus 1.42. It did the opposite. It went left. If you see a negative in the brackets or subtraction here, it means it went right. So you're kind of doing the opposite. That's just one mental hack way of looking at that. All right. That's it for this video. Take a look at the slider and play with that. That'll be, I'll put the link back up on the screen for you. It'll also be on our homepage, but there's the link for that slider you can play with and look at how it affects the equation. And I'll make another video with the remainder of this and our other 4.3 handout.